morning my dear students and welcome to this lecture series by AKTU. I am Dr. Supriya Fralatpam, Assistant Professor in BVD ITM. I will be taking Environmental Engineering KCE 603 Unit 5. So, in Unit 5 you will see that we are dealing with wastewater treatment. Wastewater treatment is one of the most important part of environmental engineering. The syllabus as you can see are here. In Unit 5 we will be talking about wastewater treatment, unit operations, processes and flow sheets, secondary and tertiary treatment, secondary sedimentation and theory of organic matter removal, working of activated sludge process, trickling filters, aerated lagoons, waste stabilization ponds, oxidation ditches and rotating biological contractors. After this we will be talking about the anaerobic part, that is anaerobic digestion of sludge, design of low and high rate anaerobic digesters and septic tank, working of a flow anaerobic sludge blanket and other emerging technologies of wastewater treatment. For preparing of this slides, I have used these two books, Environmental Engineering by PV and PV, and then Environmental Engineering Volume 2 by SK Garg. Before we start the unit, we need to know some very important terminologies about in wastewater treatment. So, when we talk about wastewater treatment, we talk majorly about some unit operations and some unit processes. So, some methods which are used for treating municipal wastewater are often referred to as unit operations or unit processes. So, what are unit operations and what are unit processes and what is the difference between them? When we talked about unit operations, we are generally talking about something involving physical forces. So, unit operations are generally involve contaminant removal by physical processes. We are using physical processes to remove those contaminants. And when we talked about unit processes, they generally involve biological or chemical reactions, right. So, operations mean physical forces and processes means biological or chemical reactions. Okay. So, another term we need to understand is a term called reactor. So, what does a reactor mean? A reactor refers to the vessels or contaminant structure along with all of its appurtenances in which the unit operations and processes takes place. So, it is like a vessel where all its operations and processes are going to take place. Okay. A wastewater treatment system is composed of a combinations of unit operations and unit processes designed to reduce certain constituents of wastewater to an acceptable limit. So, when we are talking here is about wastewater treatment. So, wastewater treatment is not only one operation or one processes, it is going to be a series of operations or a series of processes or a combination of those which are going to which will take place in a reactor and which is going to reduce certain constituents like BOD or suspended solids or etc. like that. So, many different combinations are possible. So, when we talked about it, there is no hard and fast rule in wastewater treatment ki you have to follow a particular flow sheet. There may be, depending on the type of waste you have, there is lots to be done. You can go for different types of processes, you can go for a different combinations of operations and processes. So, let us come to the next slide. When we talked about wastewater treatment, we generally talk about three major treatment systems. So, wastewater treatment is divided into majorly three processes. So, municipal wastewater treatment systems are often divided into a primary treatment, a secondary treatment or a tertiary treatment, right. So, in primary what we do? In primary what we do is we remove solid materials from the incoming wastewater. So, something solid, it is going to be solid materials. Okay. But even in but when you talked about solid material, when you see wastewater, in the sense that when you talked about wastewater, it is going to carries many things, like it may carry it may even carry dead animals, dead dead animal bodies, and it may carry this plastic sheets, it may carry that plastic bottles that which you threw out, right. So, including that, the solid material, the amount and the type is going to vary a lot. So, depending on that, operations to eliminate large objects and grids along with flow measurement is often referred to as preliminary treatment. So, in primary treatment, when you go for bigger objects like animal bodies, and you say this cardboard sheets and then the plastic bottles, for removing that, that will be called preliminary treatment. Okay. Secondary treatment consists of biological, most of the time biological conversions of dissolved and colloidal organics into biomass that can subsequently be removed by sedimentation. In most cases, secondary treatment is sufficient to meet effluent standards. So, in primary treatment we remove the solid materials, and in secondary treatment we remove dissolved and colloidal material, right. So, primary treatment you remove whatever can be, most of the time it is sedimentation tank and all these things. So, something which you generally go by physical processes, right. In secondary treatment, either you can go for physicochemicals are also there, but most of the time here nowadays we go for biological treatment. So, in secondary treatment what we are doing is biological conversion of dissolved and colloidal organics. In most of the scenarios, whatever effluent comes out of the secondary treatment is good enough to be discharged into a river or wherever you want, right. So, they have good effluent characteristics and they can be discharged. So, sometimes in most of the cases we stop the treatment as secondary treatment, but there are some certain conditions where you may need to go for tertiary treatment, right. So, tertiary treatment involves removal of suspended solids and further removals of suspended solids and nutrients. Say for example, when you want to discharge, but then there is some particular nutrients which you really do not want to go into the river stream, that time you will go for this tertiary treatment, or you feel that the effluent coming out of the treatment system for the secondary treatment system has needs to be chlorinated, then you will go for tertiary treatment. So, but most of the time in Indian context or any other context, we generally do not go for tertiary treatment in wastewater treatment system. Like when you talked about water treatment system, tertiary treatment is the most important, like you go for chlorination, which is most important, but here tertiary treatment is the least important, and you generally go for it only when certain conditions are required for the effluent standards. Now, this is a flow sheet for some examples of an STP or a sewage treatment plant or a wastewater treatment plant. So, there is no hard and fast rule that you have to follow a particular particular thing, like you have to follow this will come after that. That will be depending on the influent, the condition of the influent, you may, and your temperature and how is the working conditions, everything, you as an engineer will decide what needs to be done. So, we will only let you know what are the processes and what is the merits, the demerits, and how it is done. But then when you go to the field, you have to decide which one to keep and which ones to remove. Okay. So, in the first one you can see that is the sewage treatment plant for a small or a medium size cities. Okay. So, small or medium size cities, so you do not the population is comparatively lesser. So, most of the time what we will do is when whatever wastewater is collected from your house or from your kitchens and from restaurants and from commercial areas will finally go through the sewer to a sewage treatment plant, right. So, what will happen then, sewage treatment plant that is going to be in large sewers, then those sewers will have lots and lots of floating materials. They may have plastic bottles, papers, cardboard sheets, dead animals, soil, with whatever. Okay. So, for removing that, first we will have a screen here. Okay. So, it is going to remove coarse floating materials, racks. Okay. So, right. Then after this, after this screen we may have a sedimentation tank. Between this screen and sedimentation tank, if you want, you can include many other preliminary processes also, which we will be discussing. But in this case, after screen you are directly going to a primary sedimentation tank, which is going to sediment out all the solid organics, some organics and inorganics also, right. Then since this is a small or a medium sized city, we will go for a trickling filter, right. Trickling filter is the secondary treatment. After the effluent of the secondary trickling filter will go to a secondary treatment settling tank, which is going to remove the sludge, right. Then whatever is the sludge, it is whatever sludge will be left will be can go for a sludge digestion tank, and the effluent of the secondary treatment settling tank can be discharged into a river or wherever you want, right. For in this case here, this is the sewage treatment plant for a large city. So, so in the large city, and if you go for a village, it may be different. If you go for a smaller city, it may be different. But here in the next one, we are going to talk about a large city. And so, in a large city, what will happen? You have the screen, then you have a grid chamber. Okay, grid chamber may also be included here, but in this case we have not included. That will be dependent on the engineer. So, here you have a grid chamber. After the grid chamber, you have a primary settling tank, sedimentation tank. After that, we are going for an activated sludge tank or an ASP, as we generally shorten it. Okay. So, activated sludge and trickling filters, what is the difference? Here the rate is higher in this, okay, but then here we have lots of consumption of electricity. Here we do have less consumption of electricity. So, a large city may be able to afford that much electricity here, but here in small and medium sized cities, if you go for activated sludge, even though it may give very good results, but then economics wise it may not be a good choice, right. So, at the same time, in large cities we do not have that much area, trickling filter is going to take a larger area than an activated sludge process. So, so it will be wiser to use an activated sludge process in a large city, right. Then finally, the effluent of the activated sludge process will go to a final settling tank. The sludge, if you have the sludge, that sludge is going to go to a sludge digestion tank, and the effluent from the secondary sedimentation tank can be discharged into a river. Okay. So, this is the the flow diagram of a STP. Similarly, you may have different combinations of unit operations, unit processes. Sometimes you may put grid chamber, sometimes you may remove it. That is completely dependent on you as an engineer. So, right now, so we have talked about all these things, but right now let us discuss one each process differently. So, what does it do? Afterwards, you can choose whatever you like. It is like you are served everything in a platter. You have the choice. You have the you can from that you can choose things, right. So, the first one is preliminary treatment. So, as I told you, in my case, what I will be talking, I will be talking about primary treatment, secondary treatment, and tertiary treatment. Primary treatment, the initial part of the primary treatment is called the preliminary treatment here. Okay. So, but here, so I hope you understand. So, in the preliminary treatment, the first thing what we do is the screening. Okay. So, preliminary treatment screenings, they are used to remove coarse solids from wastewater like sticks, rags, boards, and other large objects. Okay. So, see, this is a screen. Okay. This is the screen, you can see here. See, these are the racks here. So, there are different types of screens here. It is inclined at a particular angle, and so here is, you can see here, because these plastic sheets and all these are there. So, you will pass the wastewater, you will pass the water through this screen, so that all the large objects will be retained on this side, and the water or the smaller parts will go through this. Okay. So, here as you can see here, this is another picture here. So, you will pass the water through here, all the big objects will be retained on this side, and smaller will on the water will go from the side. What is the primary purpose? So, it is like very easy, right. So, what is the primary purpose? The primary purpose is to protect pumps and other mechanical equipments, and to prevent clogging of valves and other appurtenances in the wastewater treatment. So, if you do not put a screen, what will happen? Everything will go inside the wastewater treatment plant. In the wastewater treatment plant, you are going to have lots and lots of instruments like pumps and all. So, if that big objects go inside the pumps, you are going to waste so much of money, everything is going to go waste, it is going to break down, and then you will have the repair and maintenance, right. So, you do not want that. So, for that what you do is simply put a screen, which is a very easy way and effective way of doing things, right. So, depending on the size of the openings, screens are classified as coarse screens, medium screens and fine screens. In coarse screens you have 50 mm, that is 5 centimeter. Okay. So, 5 centimeter spacings. Medium screens you have 6 to 40 mm, that is 0.6 to 4 centimeter spacing, and fine screens you have perforations. Okay. These are spacings and this is a perforations, like it is going to be like this, fine screens. Okay. So, generally we do not use fine screens because it gets choked many times. It is very fine, everything, it gets choked very times, so maintenance is very high. Most of the time we go for coarse screens and maybe medium screens, because after screening we are going to have other preliminary treatment. Okay. Then since after screening, what you do generally do? The next preliminary treatment is commutators. So, what are commutators? It is actually simply a shredding device located across the flow path and shredding the coarse solid to about 8 mm in size, right. So, whatever happening is, so you have the screens. After that, generally you may have or you may not have a commutator actually, right. So, what is it going to do? It is going to all the particles is going to go inside. This is going to shred, it is a rotating cutting machine. So, whatever is going to shred into smaller particles like this, okay. And this is this is how it looks like generally. So, the water will go inside, this is going to shred it cut it into smaller pieces, and then it is going to go outside. Okay. So, the device generally consists of a revolving slotted drum through which the sewage is screened. It is actually a very high maintenance device, right, because if it is not able to cut through something, then obviously it is going to get choked, and then you have to call a maintenance person, right. So, it is a high maintenance device, and provisions should be made to bypass the unit when repairs are needed. So, most of the time screens are actually very useful, but then the shredding machines are not sometimes, most of the time not used, and they are generally not used in India, right. So, this is a possible thing, you may use it or you may not use it, but then in India generally it is not used, because Indian waste, we have so much of waste, and if anything goes, the maintenance is so high that we do not we generally do not want it. Okay. So, the next preliminary treatment is called grit chambers. Grit chambers is actually very important, extremely important, right. So, most of the time we go for grit chambers in India or everywhere, right. So, why is it very important? Grit chambers or detritus tanks are sedimentation basins placed in front of the wastewater treatment plant to remove inorganic particles. So, what you have to remember about grit chambers is that they are inorganic particles. They remove inorganic particles such as sand, gravel, grit, eggshells, bones and other non-putrescible material that may clog channels or damage pumps due to abrasion, and to prevent their accumulation in sludge digester. So, generally when we talked about grit chambers, the first thing you have to remember is the term grit. So, if you go and check it out in a dictionary, you will find that the meaning of grit is small stones or pebbles like small sand like so. So, what are grit chambers? Grit chambers are generally they meant to remove all these small stones, pebbles like this. So, generally they are the inorganic particles, right. So, you generally in grit chambers you do not want to remove any organic particle, you are going for inorganic particles like sand, clay things, right. So, what is the thing? They are designed so that the flow velocity should neither be too low as to cause settling of lighter organic material, right, or nor should it be so high as to cause settlement of the entire slit and grit present, right. So, grit chambers they design that in such a with such a velocity, with such a speed, the flow velocity should be that it should not cause settling of organic matter, but it should cause settling of inorganic matter. So, what you want in grit chambers are organic matter So, what you want in a grit chambers are organic matter to flow trick and inorganic to settle, right, and organic to flow, right. So, they are designed so that the flow velocity should neither be too low as to cause settling of lighter organic material, nor should it be so high as to cause settlement of the entire slit and grit present in the sewage. So, what you want in grit chambers is that you want the inorganic to settle down in the grit chamber, right, and you want the organic to flow out, right. So, they are generally placed after the fine screens before the primary sedimentation tank. They are placed before the primary sedimentation tank, okay, most of the time. The design velocity is around 0.25 to 0.3 meter per second. So, when you design a grit chamber, you generally design for the velocity. This is at this rate what will happen is that as such generally what will happen, the organic matter, the density of the organic matter is going to be lesser than the density of the inorganic material. Inorganic material like soil and this rocks and slit and all, they are going to have a specific density of around 2.65 or 2.6 you say, whereas the organic matter is going to have a specific the density of around maybe specific density of around maybe 1 plus, less more than water, but then lesser than this. So, that is the principle behind it. You want the denser material, you want a heavier material to settle down, but then you want a lighter organic matter to flow off. Okay. So, the design velocity is around 2.5 to 3 meter per second. The tension period is generally 40 to 60 seconds. So, you are generally it is a very less detention period, right. So, around 40 to 60 seconds for rectangular grit chambers with proportional flow weirs and around 2 to 5 for aerated grit chambers. So, even in grit chambers you have different types of grit chambers, right. So, for generally other aerated grit chambers you may have 2 to 5 minutes of detention time, generally around 3 minutes. Then next is the skimming tank. What is skimming tanks? Skimming tanks are also very important. They are used to remove oil and grease from sewage, right. So, they are generally placed before the supplementation tank and used when sewage contains high amount of grease and oil. So, if a sewage contains high amount of grease and oil, you generally use this. Okay. If not removed, oil and grease may form unsightly and odorous scum which may interfere with the working of biological processes like activated sludge and trickling filters. So, what will happen? So, generally this is how a skimming tank looks like. So, what will happen is generally you actually what happens is air is blown by an aerating device through the bottom which will coagulate and conceal the grease on the surface which may be removed easily. So, in generally a skimming tank you are blowing air from the bottom, right, and you are mixing sort of the air is going to mix up all these things, then the all the oil and the grease is going to go on the top, right, and then this can be coagulated and this can be taken out through this scum trout. Okay. So, and this can be taken out through this scum trout. So, that is what a skimming tank is used for. Detention period is around 3 to 5 minutes, but in India generally we do not use skimming tanks because you know India is a hot country. So, generally we are not able to do this hot oil and these things, they are generally in liquid form, but we do provide this skimming tanks in India also, but in colder places like Shimla, you know, the hill stations Shimla and Nainital and wherever you want, if it is colder places, what will happen that those oil and grease may be they may solidify, right, and it may be a problem for those places. So, they are provided in places like Shimla and colder places and hill stations like Shimla, Nainital, wherever you want, right. So, with this thank you, and in the next slide in the next lecture we will be talking more about preliminary treatment and thank you so much.